Hello, math humans. We're going to do 2.4a today. We're going to be talking about the chain rule. Our objectives are that we're going to use the chain rule to find derivatives. So I have heard this explained lots of different ways. Some people will say what starts inside stays inside, and then other people have said the junk inside stays inside. So let me illustrate what that means. The chain rule is used when I have things attached to the function or I have a composition. So let's say I have a derivative of f of g of x, then that is f prime of g of x, and then times g prime of x, okay? So I think this gets to be a little bit confusing, so I want to explain it a different way, and I'm going to explain it with some pictures, so bear with me. If it's not helpful, I'm sorry, but we'll figure it out. So let's say I have a function, and I have another function inside, and let's say that function is squared. So before I do that, let's go back and just do the derivative of the box. So let's say I have the derivative of a box squared. Well, then that would be 2 times the box raised to the first power. So that would just be the power rule for a derivative. But now if you'll notice, I have stuff on the inside. So here's the way the chain rule works. What starts inside stays inside. So I'm going to manage the chain rule first. So my little triangle started inside, so it's going to stay inside. And then I have to take the derivative of the triangle. So that is the chain rule. So I manage the whole thing first, and then I take the derivative of whatever's inside. Well, now let's make it a little bit more complicated, and let's do the derivative as I move my picture up. And let's do the derivative of a box. Let's say it's raised to the third power. Inside the box is a circle, and inside the circle is a triangle. So let's do the chain rule. So the derivative would be 3, and I would start with the whole thing, and that would be squared, and that's just the power rule. And then I would have to take the derivative of what's inside, which is the circle comes next, and then I would have to take the derivative again of the triangle because now it had 2 things inside. So that was the circle and the triangle. What started inside of the circle was the triangle, so it stayed inside, and then I have the derivative of the triangle. I don't know if the illustration helps, but that is just a way that I have tried to explain the chain rule. So let's just start with our first example. So I have y is equal to x squared plus 1 to the third. Okay, and you'll notice it looks a little different than what we've done in the past because now the inside of the function has stuff going on. And I want to find f prime of x. So I'm going to start with the chain rule. So f prime of x, I'm going to manage the whole first. So it's going to be 3 x squared plus 1 to the second. And then I'm going to take the derivative of the inside, and the derivative of x squared plus 1 is 2x. And now I'm going to clean that up a little bit, and I'm going to write f prime of x. 3 times 2, this is going to be 6x times x squared plus 1 squared. And I would stop there. I would not try to simplify that anymore. Okay, let's do some more examples. Example number 2. Y is going to equal the third root of x squared minus 1 squared. So this one has 2 chains. Okay, so I'm going to, actually it's 1 chain, but I'm going to rewrite it. I'm going to write this as x squared minus 1 squared raised to the 1/3 power. And remember, a power to a power is multiplied, so this is x squared minus 1 to the 2/3 power. So now it's just 1 chain. So when I take the derivative, the 2/3 comes out front. What starts inside stays inside. 2/3 minus 1, okay? And then I'm going to have times the derivative of the inside, okay? So when I clean this up a little bit, this is going to be 4x over 3 times x squared minus 1 to the negative 1/3. And then I want to clean that up some more. So we have 4x in the numerator, and I'm going to have a 3, and then I'm going to have the third root of x squared minus 1, and there is my derivative. So what you have to be careful with the chain rule is making sure that you don't forget to take the derivative of the inside. All right, the third example, we're going to have y is equal to sine cubed of 2x plus 7. So this is the chain rule because now it's not just an x on the inside, but I also have a power. And so one of the ways that it helps, I think, to think of this is to rewrite it like that. And so now, if I work on, there's your directions, if I work on the derivative, f prime of x, what starts inside stays inside. So I'm going to manage the 3 first, and then I'm going to have the sine of 2x plus 7, and then the squared goes right there, times the derivative of the inside. So the first thing is the sine. So I typically don't write times the derivative of the sine of 2x plus 7 times the derivative of 2x plus 7. I just tend to manage as I go. This is technically how you would write out the chain rule. I just manage my math. So the first thing that I had is the sine squared of 2x plus 7. The derivative of sine would be the cosine of 2x plus 7. And then the derivative of 2x plus 7 is 2. Okay, and so this is this math. The derivative of this statement is this. The derivative of the inside is this. So this was one of those chains that had multiple chains. Now I would clean this up. So this is going to be 6, and then I have sine squared of 2x plus 7 times the cosine of 2x plus 7. Okay, so that one was a little bit more entertaining. All right, for our next example, so this is going to be example number 4. It's going to be a little bit more unique. So I try to pick unique problems to make sure that you see lots of different types of problems. And I want to know what is the derivative. So if you'll notice on this one, I have a thing multiplied by a thing, which means that I'm going to have to do the product rule and the chain rule. Okay, and you might want to watch this a couple of times because I'm going to talk you through it. So when I take my derivative, f prime of x, it's the first thing times the derivative of the second. I'll write out the long notation of 3x minus 9 to the third plus the second thing, 3x minus 9 to the third, times the derivative of the first, okay? And when I take the derivative of this is going to be the chain rule. So this is the product rule. First thing times the derivative of the second plus the second thing times the derivative of the first. Myself, I don't write this notation. Here would be how I'd manage the math. So I would say it's the first thing times the derivative of the second, so it's going to be 3x minus 9 to the second, times the derivative of the inside plus the second thing times the derivative of the first. Okay? That would be how I manage that math. Now, before you start expanding and distributing, notice that I have these two factors in common. So I'm going to start, this is 9x times 3x minus 9 squared, and I have plus 3x minus 9 cubed. I'm going to factor out a 3x minus 9 squared, and it's going to leave 9x plus, and then one of these, 3x minus 9. So I get 3x minus 9 squared. 9 plus 3 is 12x minus 9. And this would be where I stop. There is absolutely no reason to expand this because this is a binomial, then times another binomial, and that just gets gross. So I would stop here. Alrighty? So we're going to do another one of these. It's a little bit more complicated, so I'm going to give myself a whole nother sheet of paper. But if this notation helps you, by all means do this notation. I typically don't do that, but it doesn't matter. A lot of people need this to help them keep their math straight. All right, so let's start the next example. And if I remember, yep, this is our last one. Woohoo! It just happens to be a long one. All right, so this function is going to be 1/2 x squared times 16 minus x squared to the 1/2. And I want to know what is the derivative. Okay, so I'm going to rewrite, actually I'm not going to rewrite this, but what I'm going to tell you is I have a product rule and I'm going to have a chain rule because I have stuff on the inside. So when I start my derivative, f prime of x, I'm going to do the product rule first. So the product rule is the first thing times the derivative of the second, so 1/2 times 16 minus x squared to the 1/2 minus 2 over 2 times the derivative of the inside, a negative 2x, plus the second thing to the 1/2 times the derivative of the first, which is 1/2 times 2 and x. There's my second thing. So let's just make sure I got all of my pieces. Okay, so it's the first thing times the derivative of the second. The power came out front. Here's the inside. This is going to be to the negative 1/2 times the derivative of the inside. This is my chain. Okay, this is the product. This is the chain plus the second thing times the derivative of the first. So now I'm going to do a little bit of cleaning. This 2 will cancel. I circle the negative so I don't lose it. Okay, and then these 2's cancel. And again, do not distribute. So I'm going to clean this up a little bit. So now I have a negative x to the third over 2. And then this is going to be to the negative 1/2. So I'm going to have times 1 over the square root of 16 minus x squared, because that's to the 1/2 power. And then plus x times the square root of 16 minus x squared. Alrighty, and I'm going to clean this up a little bit more. So this is a negative x cubed over 2 times the square root of 16 minus x squared, and then plus x times 16 minus x squared. So now we have some algebra to do to put these things together. Depending on what the problem is asking you to do, you could stop here. But if this were a multiple choice test, and this answer weren't there, the reason is they would probably have gone further to simplify. So to do that, I'm going to put these two fractions together. So I'm going to multiply this fraction by 2, and then 16 minus x squared over 2 and 16 minus x squared, because that is my lowest common denominator. So I'm going to get a negative x cubed plus, and then these two multiplied together, 2x times 16 minus x squared over 2, and then 16 minus x squared. Yay, algebra. If I simplify the numerator, here's the x cubed, and then I have a 32x minus 2x cubed over 2 times 16 minus x squared. So this is a negative 3x cubed plus 32x over 2 times the square root of 16 minus x squared. You never have to manage having radicals in the denominator, which is why we quit doing that in pre-calc, because you don't need to do that in calculus. So that was entertaining as far as the algebra goes. All right, that's it for today. I will see you soon.